What is a space hurricane? Is it dangerous? And how does it form? A space hurricane is a massive spiral geomagnetic storm that happens above the Earth's polar ionosphere amid extremely quiet conditions. They are related to the aurora borealis phenomenon, as electron precipitation from the storm's funnel produces massive, cyclone-shaped auroras. It is essentially a collection of solar particles that are interacting with different gas molecules from Earth and rotating around the magnetic pole. Because they are day-side aurora, space hurricanes are unlikely to be visible to the naked eye most of the time, as sunlight will make it difficult to see any auroral features. To see it in the winter, you'd have to get near the poles. Now we know what is a space hurricane. Now let's talk about how it basically forms and where space hurricanes form. Plasmas, which are made up of extremely hot ionized gases that rotate at incredibly high speeds, with rotational rates reaching up to 7,560 km per hour, make up space hurricanes. Researchers identified a large space hurricane that occurred over the Arctic in 2020, spanning 1,000 kilometers in diameter at its base in the ionosphere. The ionized upper atmosphere at an altitude of 110,860 kilometers, and roughly centered over the North Magnetic Pole. Based on observations made on August 20, 2014. A cyclone-like auroral spot with multiple spiral arms due to precipitating electrons. Strong circular plasma vorticity with zero horizontal flow at its center. A negative to positive bipolar magnetic structure. And a large and rapid deposition of energy and flux into the polar ionosphere were all characteristics of the space hurricane. In the northern hemisphere, the storms spread from the ionosphere upward along geomagnetic field lines to engulf a considerable portion of the dayside polar magnetosphere. The space hurricane also had many spiral arms, similar to traditional hurricanes, and revolved counterclockwise. Instead of raining water, the enormous plasma storm poured electrons. A prolonged auroral spot was coupled with a strong, upward, field-aligned current created by precipitating electrons in the calm middle area, ringed by the revolving plasma. Below the storm, the electron rain created a massive cyclone-shaped aurora. Unlike ordinary space weather disturbances, the space hurricane was detected during very tranquil geomagnetic conditions, when the solar wind flow was slow and the interplanetary magnetic field was pointing northward, whereas conventional geomagnetic storms require a substantially southerly inclination. This adds to the similarity with hurricanes in the lower atmosphere. According to a weather meteorologist, hurricanes require weak winds aloft to form. Now let's talk about how it will affect us and will it be dangerous? While the space hurricane would have had limited influence on Earth's surface, electron precipitation from such storms in the ionosphere has the ability to impair communications, GPS satellites, and radar operations, as well as modify the orbital patterns of space junk at low orbital altitudes. This, according to the researchers, emphasizes the significance of continuous and enhanced space weather monitoring.